Hi everyone, today we're looking at quadratic regression. Now this is going to be very similar to what you already did with linear regression. So don't worry, we're going to repeat a lot of steps. It should really help you feel even more comfortable with how to do regression and modeling on your calculator, right? So you can use quadratic regression feature of a graphing calculator to model data with a quadratic function. Quadratic regression is the process of finding the equation of the parabola that best fits a set of data. And we're going to just go ahead and get right into it here. We're going to do steps to calculate the parabola of best fit. And as you know, it's always best practice to clear all your lists first. So we're going to do second, plus sign, number 4, clear our lists. And we're going to enter our data into our calculator. So you're going to go to Stat Enter and enter your data set. And remember, it's always a really good practice to just take 5 seconds and just look at your data and make sure you've typed it in correctly. Right? Once we're ready, we're going to exit our list. We have to get back to the home screen. So we're going to do second mode to quit out of there, get us back to our home screen. Now, just like when we were calculating linear regression, we're going to do stat, we're going to go to calc, and instead of picking number 4 for linear regression, we're going to pick number 5 for quadratic regression. We want list 1, so second 1 if you don't have it there. Second 2 if you don't have list 2. Nothing in frequency. That stands for store regression equation. We don't need that right now. And calculate. All right, so we've come up with our equation. All right, so in regression, the coefficient of determination R² value measures how well a graph approximates the real data points. And R² equal to 1 indicates that the regression graph perfectly fits the data. So if we look at our data, again, going back to that, our R² value in this case is 0.91, and that means that our equation fits our data very well. Right, now the rest is all practice problems, so I would welcome you to pause the video and practice and then come back and watch and check your solutions. So number 1, use quadratic regression feature of your calculator to find the function that models the data in the table. Find and interpret the coefficient of determination. So we'll go to our calculator. We're going to do second plus sign, clear all lists. I'm going to go back to stat, and we're going to enter our data. Make sure you use the negative, not the subtraction for these. We're going to do stat, calc, quadratic. And we'll copy that down. All right. If R² is 1, that means that our function is a perfect fit to the data. Or I'll say our model is a perfect fit for the data. So let's look at our data just so you can see what that means. We have our scatter plot on. We're going to put in our equation that we found. And we're going to do zoom 9 to look. And you can see that, look, we have our 3 points and our model is hitting and going through every single point. So we have a perfect fit. All right, number 2, the table shows the height of a column of water as it drains from its container. Find a quadratic model for the data. Back to your calculator, home screen, clear your lists, stat, enter your data. Take a moment to review your data, make sure you've entered everything correctly. Once it looks good, you want to go back to your home screen. All right, and now we're going to calculate our quadratic model. All right, so for the first value of A, notice that we're going pretty far out. It's really 0 if I round to like the nearest tenth. So I'm going to round this guy out a little bit more so that when we make a prediction with the model, it'll be a little more accurate. So if we're having a quiz or a test, I'll always be really clear what number to round to. But for this particular problem, I'm going to round out letter A pretty far out so that our model is a better indicator again when we make our prediction. Find the coefficient of determination. We will just look at the r-squared value, and that rounds from 0.999 to exactly 1.00. It says graph the data and the function on your calculator. Y equals, we're going to enter our new function. I'm going to go to zoom 9. Make sure you always do zoom 9 to fit the window to your data. Okay. Use the model to estimate the water level at 35 seconds. So we're going to go to our calculator. And at 35 seconds, we have 57.73. Which is approximately 58 millimeters. Now I do have a note here. You could do it the way I just did it, or you could also use the table feature. So we would go to table and we would look for the value of 35. Now I'm really far away from 35. So I'm going to set my table. I'm going to use the table set feature. All right, so if you go to second window, you can tell your calculator at what value to start when I, go to my table. So I want to go right to 35. And now when I go back to table, you see I'm right there and it gives me 57.73. So that is another way of doing letter D. All right, the next question says, use the quadratic model to predict the water level at 3 minutes. Well, we've been working in seconds. So 3 minutes is exactly 180 seconds. 3 times 60 is 180 seconds. All right, so if I try to put 180 right here, I'm going to get an error because I don't have the X value of 180 in my window. So instead, I'm going to use my table. All right, and I'm really lazy. I'm at 35. I don't feel like scrolling. So I'm going to go back to table set. I'm going to enter 180. And I'm going to go back to my table. And it'll put me right there. That gives me 39.011. all right, which is approximately 39 millimeters. All right. Is your prediction in part E reasonable? Okay, no, the tank is empty after 109 seconds. So you have to, remember to take these problems and really be thinking about what you're doing. At 3 minutes, right, we're not going to have any water in there. All right, for the remaining questions, just continue on. You're going to go ahead and clear your list. You're going to go back to Stat. You're going to go to Edit. You're going to enter your data. Make sure you do Zoom 9 to look at your data. Looks like we have a perfect fit. We want to estimate the height of the ball at 2.5 seconds. So we can do and we get 28.5. All right, the table shows the percent of US houses with cable TV. All right, it says find a quadratic model using 1960 as year 0. So these are going to be your X values, 1970 is year 10, and so on. And we're going to use that data now in our calculator. Same process. Clear your lists, enter your data. Your coefficient of determination is 0.96. That's a very close fit. And then use the model to estimate the percent of households with cable TV in 1995. Now, be careful here, right? We're saying that 1960 is X equals 0. So 1995 is X equals 35. I'm going to enter my new equation. Zoom 9. I'm going to do second to get my value. I'm going to enter it in for 35. And I get 54.26. Okay, last problem. The table below gives the stopping distance for an automobile under certain road conditions. All right, so this is a good one because we're going to be actually finding two models here, the linear model and the quadratic model. Clear your lists, enter your data. Take a moment to make sure you've entered the data correctly. Go back to your home screen. Now, the first thing we're being asked to do here is come up with the linear regression model. So we're going to pick number 4 first. And we're going to write down that model. And we want to write down the coefficient of determination. Now be careful, that's r, not r squared. All right, so the correlation coefficient is r. We're looking at r squared, so that's 0.98. Now we're going to find the quadratic model. Go back to Stat, Calc. This time we're going to pick number 5. And we're going to write that down. In this case, our r squared is equal to just about 1. Compare the models, which is a better fit, okay? The quadratic model is a better fit because the r squared is closer to 1. Okay, everybody, I hope you're feeling good about this lesson. Have a great day.